Welcome guys. I have done a video for GCE students, NECO GCE students. If you have not seen that video, please go and check it out. I've talked about the alternative to practical, what to expect. So, and I told you that for number one, I will do another template because for number one, we have titration, sort analysis. I've said that in my last video. Okay, so if you have not watched the previous video, go and watch it. And I'll put the link in the comment box section so that you are going to see it. So for the number one, I've solved that one I gave. Go and watch it very carefully and beautifully. So the question number one can come in this format. Let's go to this. Look at this. Did you see that there is a table? If you check the first one I did, there was no table. Did you understand that? So you can be given questions like this too. Yes, that's why I said I'm going to do another part so that you understand how number one can come. Is that they are giving you like this or they are giving you like the one I did, the first one? If you have not watched it, please go and watch it. Now, let's take a look at this question. They said A is a solution containing 2.0 gram in 250 centimeter cube solution of tetraoxosulfate 6 acid, okay? B is a solution obtained by taking 25 centimeter cube of saturated solution of sodium triisocarbonate 4 at 25 degrees Celsius and diluting it to 1000 centimeter cube of distilled water. Okay, perfect. An experiment was carried out. Did you understand that now? They have already carried out the experiment. That's why it is alternative to practical. By titrating A against 25 centimeter cube of B using meteoring as an indicator. The result of the experiment is presented in the table. Did you see that now? So which means they did not give us some of those values directly. Like our theta value now, they did not give us. So we have to complete this table now to now get our theta value. Then from there, we can also. So what do we do? The first thing that I'm going to do here is, please note this. This one is a bit tricky and you can lose a lot of mark from here. The first thing to do here is make sure that the units are written. Did you see they did not write the unit? So rough is a centimeter cube, right? All this one will be written. That's the first thing to do. Second, centimeter cube, centimeter cube. Very important now. They've given us, they said this one is meteoring, they've given us all that thing. Now, if you are used to titration, what do? We used to subtract the initial from the final. That is it. So which means if I need to get this, I need to subtract this from this. Did you get that? So if I subtract this from this, which means if I need to get this, I need to add this plus this. Did you see? And the first one I did, they just gave us the theta value directly, but this one it is not so. So you have to be very careful. So which means this minus this is going to give us what? This minus this. Let's use our calculator. Don't be too confident to avoid any mistake. You have your calculator on that day. Minus 1. So this is 26.60. So this plus this will give us this. This minus this will give us this. Do you understand that now? So that means this plus this is going to give us 29, right? Point what? 0.00. Does that make any sense now? Then this plus this again. Did you get that now? Because this minus this will give us this. Did you see the trend? This minus this will give us this. So which means this. Now if I'm looking for this, what do I do? This minus this too will give me this. Did you see that now? So which means 36.40 minus 26.40. So this will give me, I hope you are getting the trend, please. This minus this will give us this. So if this minus this gives us this, this plus this will give us this. For me to get this, it will be this minus this. Did you see? This minus this will give us this. Did you get that now? So from this one now, I'll say this minus this. So 36.40 minus 26.40. This is giving me 10. So I have 10.00. I want to believe this is clear now. Then this plus this will now give me this. So 26.50 plus 6 plus 6 will give me what? 32.50. Now let's check the trend again. You see, this minus this will give this, correct? This minus this will give this, correct? This minus this will give this. Did you get that now? This minus this will give what? Will give this. Did you get that? So that's very correct. I can see we have completed the table. Now the question now says calculate the average volume of acid. Now look at this. Look at the rough. 27. Look at the first. 26.60, 26.40, 26.50. You see these ones are closer. This rough is far from this one, so I will use these 3 to get this. Did you see? So the other one I did, they gave us the average volume of acid use, but this one they didn't give us. You are just completing table, so the question can come like this. Okay, so for this one now, our A Roman figure 1 now, they say calculate the average volume of what? Of acid used now. So I'm taking these 3, so 26.60 plus 26.40 plus 26.50 divided by what? By 3. So my VA will be, let me use my calculator again, 26.60 plus 26.40 plus 26.50 divided by 3. So that's giving us 26.50. 26.50. The unit centimeter. Now come to the table again. Did you observe something in my table? That all the values in my table is to 2 decimal place. Did you see that? 2 decimal place. Did you see it? Very important, because mark will be awarded for that too. And very important, did you see centimeter cube means everything here will be centimeter cube, everything here. So the unit, the decimal places are very important. You can lose mark there. That's if the question comes like this. You have to be very careful. So the next one is a 2. The mole concentration of A in mole per dmq. Let's come to this place. Mole concentration of A in mole per dmq. What is A? 2.0 gram in 250. Did you see something now? 2.0 gram in 250. And we have said the standard measurement. Did you remember? 1 dmq. And what's 1 dmq? 1000 centimeters. So they gave us this one in mass. I told you something. I said when you see mole concentration of A in mole per dmq, the first formula that will come to your mind is mole equal to mass over molar mass. Did you see that? So the mass, you know this is in 250. Of course, I can convert it to 1 dmq, which means the mass is given. I'll work out that now. The molar mass, can I calculate the molar mass? Yes. They said tetraoxosulfate 6 acid. In fact, they gave us the equation of reaction. Did you see that? They gave us the equation of reaction here to be what? To be H2SO4 sodium carbonate. So I can get that. What do? I can say that the first thing I will do, let me divide my board. So the first thing I will do here is that I will say mole equals mass over what? Over molar mass. Did you understand that now? Now, the first thing, our mole, let's get all the parameters. The first thing is the mass. Let's get the mass. Look at the mass they gave us. They said 2.0 gram in what? In 250 centimeter cube. That's the mass. And we know we cannot use this, the standard measurement, because we are calculating in mole per dmq. Definitely this one too should be gram per dmq. I can now say since 2.0 gram in 250, 1000 centimeter will be what? Will be x. Did you see that now? So I can see cross multiply. X will be 2 times 1000 over 250. Did you see that now? So our x will be 2 times 1000, 2 times 1000, right? Divide 250. And that's giving us 8 gram per dmq. 8 gram per dmq. So the mass, because I want to calculate a mole per dmq, definitely the mass I will use must be in gram per dmq. This one is sorted. Did you see they did not ask you to calculate this? But there is no way you will not get this if you want to solve that. So that's the mass. Let's get the molar mass now. Molar mass of H2SO4 now, right? So we have, look at this, they are giving us all this here. Look at it. The atomic masses will be given, so we can now calculate. So we have 1 times 2 plus 32 plus 16 times 4, right? So we have 2 plus 32 plus 64. And that will give us what? This 36, right? That will be 30, this is what? 34, and that will be what? 98 gram per mole. Please, those units are important. So did you see that we are on the right track now? So we can calculate the mole now, because we have the mass, we have the molar mass. Very simple. Just understand what they have given you and what you need to get. That's all. So our mole now will now be what? The mass now What's the mass? 8 gram per dm cube over 98 gram per mole. Now look at the question. Question says mole concentration in what? In mole per dm cube. So look at it now. Gram will cancel gram. Did you see what is remaining? That's all. So we have our mole. So let's use our calculator now. 8 divide 98. 8 divide 98. That's 0.0816. Did you remember what I told you about 3 significant figures? So we have 0.0816. These 3 significant figures now. Mole per dm. Did you see that now? So if you look at the difference between the first one I did and the second one is that this one has a table you are completing. The first one, they gave us what we need in the question and we can just pick them out and solve. But this one we need to complete a table. But the methodology of the way we do the calculation is still very similar if you understand the concept. So I think that is very clear now. The third one now, they said mole concentration of B in mole per dm cube. Let's come to B. They gave B is a solution obtained by taking. What they gave us in B is only the volume taken. They did not give us the mass. They did not give us the molar mass of B. Did you get that? Sorry, they did not give us the mass and they did not give us the mole of B. Did you understand? They didn't give us mass, know anything about the mass of B, know anything about the mole of B. And I've told you, if this doesn't work, which one will work? If you have been following our channel, the titration formula will work. So the third one now, I can now use CA VA over CB VB equals to NA over NB. Does this make sense? So concentration of A now, we have gotten that. Look at that. Concentration of A, that's 0.0816 times the volume of A, that's the data value we got. Did you see that now? 26.50 over concentration of B. Did you know that that's what we are looking for? Mole concentration of B. So that's what we are looking for. CB times the volume of base. Let's go. They said an experiment was carried out by titrating A against 25 centimeter of B. That's the volume of this 25 is different from this 25. This is the volume of the pipette, but this is the volume of the B they took. Do you understand that now? They said 25 centimeter cube of saturated solution. So out of the 1000 centimeter cube of B they prepared, out of this, they took this, they now dissolve it in 1 dm cube. Do you understand? So this 25 is different from this 25. This one is the volume of the pipette. This one is the what? Is the volume of the saturated solution taken. They now what? They now dilute it with 1 dm cube of water. Do you understand? So volume of B, that's 25, that's volume of pipette, equals number of moles of acid. Look at the question of reaction, we have 1 to 1. Did you see 1 mole of this to 1 mole of this? So that's 1 to 1. So we have 1 to 1. So our CB is going to be 0.0816 times 26.50 times 1. Then we are dividing by 25. Did you see that now? That all these things are still. So we have times 26.50 divided by 25. So we have 0.0865 approximately to 3 decimal. 0.0865 mole per dm. I want to believe this is clear. You can see this one is faster because we are getting to understand all those things. Then the next one, they said mass concentration of B in gram per dm cube. You should not be in mole again, it should be gram per dm cube. Since we are saying mass concentration of B in gram per dm cube. So the mass concentration of B in gram per dm cube. What do we need to do there? Very simple. We'll go back to our formula, right? The mole of B has been gotten. This is it, right? And we can get the molar mass of B because they mentioned it there. They say saturated of sodium triisocarbonate. And they gave us this. So I can get the molar mass. So from there I can say molar mass of Na2CO3. They'll give us sodium 23 times 2 plus 12 plus 16 times 3. Did you get that? Just like we are calculating the relative atomic mass or the relative molecular mass. So we have 46 plus 12 plus this is 48. If we add this together, this should give us this 12, that should be 106 gram per mole. This is 106. Did you understand that now? So from there, the next time we should look for what? The mass. So mass, you now do what? Mole times what? Times molar mass. How did I get this? I'm just making mass the subject of formula here. If I make mass the subject of formula, it will be mole times molar mass. So from there, our mass becomes, what is the mole? We have gotten that 0.0865 times what is our molar mass? 106. You can see for all the values that I'm using, I'm getting them because there are marked for it. So 865 times 106, and that's giving us 9.17224 to 3 significant. So we have mass to be 9.17 gram per dm. I want to believe this is very clear. Did you see the way we are solving these things now? I want to believe this is very, 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 very clear. Should be very, very, very clear now. Okay, now the next one, solubility of B. Let me erase this now as I finish up. So I'm giving a part 1 and part 2 of how number 1 can look like. Is either coming like this or like the first one. Either of the two, you are good to go if you have carefully studied it. Now they say solubility. Let me start from this. I love to teach from the grassroots so that you understand. I want to do 2 things here. Same thing, different formula. If you understand, you are good to go. Solubility. If you remember the solubility formula, when you did solubility, the amount of solute in a solvent in 1 dm cube of the solvent, amount of solute in 1 dm cube of the solvent. That's what they define solubility for you guys to be. Now, that's not even where I'm going to. Where I'm going to is this. For solubility, they gave you a formula. Look at the formula. Solubility. They gave you that formula, very common formula, is equal to mass over molar mass times 1000 over volume. If you have done solubility in your school, you should be familiar with this formula. That's the common formula for solubility. Now, let's use this now. Solubility, because it's one you are familiar with. So what is the mass now? 9.17. Did you see that? 9.17 over, what is the molar mass? We have gotten that. You can see, I'm picking everything from my solution. 106 times 1000 over, what is the volume? If you read the question, if you have written it, they said 25 centimeter cube of B. I've erased it, but if you go back, rewind the video back, wrote 25. That's why I was saying that 25 is different from this 25. This 25 here is the volume of the base that we use. But that other 25 is the volume of B we diluted in 1 dm cube. Is that not? So that will be 25. So our solubility will be equal to, let's have what our answer is going to look like, times this. So we have 9.17 times 1000 divide 2650. That's giving us 3.46. So our solubility is 3.46 what mole per dm. Look at that. That's our solubility. You know this formula. Now, the solubility is 3.46 mole per dm. I said I can sort this in around 4 ways, and it will be giving me same thing. And these are things I've still done on this channel. Now, if you remember my first video, I talked about dilution factor. I want to solve this in another way. I talked about dilution factor, right? And I said dilution factor is V2 over V1. Let's use this to solve this. You are surprised, right? Don't be surprised. That's why this chemistry hangout. We are here to simplify all these things. Now, if you remember, in the question, I erased the question. In the question, they said we have 25 centimeter cube. We now diluted it in 1000 centimeter cube of water. That's what the question is saying, right? So, which means this will be my V1, this will be my V2. Does that make any sense? Okay. So, dilution factor will be V2, that's 1000, over V1, that's 25. If you are just, for you that fast forwarded it to this place, if you don't understand this, because you didn't get the question, so go back and watch from the beginning. You will see the question that they said 25 centimeter cube of saturated of B dissolved or made up to 1,000 centimeter cube of water. That's how we got this. So the dilution factor will be 1,000 divided 25. That will be what? 40. Did you get that? So I can now say my solubility in mole per dm cube will now be 40 times what is the concentration of the base. Let's go back. What's the concentration of the base? 0.0865. 0.0865. Okay, so let's see now. 40 times 0.0865. Look at the answer. Did you see that now? Same answer, right? Yes, same answer. So that will be what? The solubility will be what? 3.46 mole. I'm just solving it like this so that you will understand that all the formulas we give here, they are important and you need to know them. So I can solve like this, I can solve like this, I can still use another method, I can still use another one, but let me save you the stress. Let me say this too is fine because I've made mention of this in the first video. That's how to relate this, and you guys can relate to this because this is a normal solubility formula. You know, when we do that topic solubility in school, this is it. So this and this, I want to believe you have added something to your knowledge with this thing. Okay, so the last one now, concentration of hydrogen ion present in 1 dm cube of the solution. That's the fourth one now, which is the last one. Is it the fourth one? Oh, sorry, that's the sixth one now, which is the last one. So concentration of hydrogen ion. Hydrogen ion, if you remember, what is the definition of an acid? An acid is a substance that produces hydrogen ion or hydrozonium ion as the positive ion when dissolved in water. Don't mind my grammar, I'm just trying to. These are just definitions. But what are we trying to say? That because the acid is H2SO4, you get that? It means that if this acid dissociates, we are going to have 2H plus, then we are going to have SO4. That's the dissociation reaction of H2SO4. Did you get that? Which means that 1 mole of H2SO4 gave how many hydrogen ion? Because this is our bone of contention. Hydrogen ion, that's our main concern. So hydrogen ion is giving us what? 2 moles of hydrogen ion. So from the equation of reaction, 1 mole of this will give us 2 moles of this. But let's now go to concentration of A because we want to know that now. Concentration of A. Now look at it. This is the concentration of A. So it's 0.0816. So how many mole is going to be in this? Did you understand? Because this Ca, this is our concentration of acid. So how many moles of hydrogen ion will be here? So which means from the equation now, if 1 mole of this is equal to this, it means that 0.0816 will be what? Will be X. Did you get that? So X times this will give us X. So it's 0.0816 times 2. Let's have the answer. It's 0.0816 times 2. It's giving us 0.1632. It's 0.1632. So let me leave it at 3. 0.163. Since we said 3 significant. So concentration of hydrogen ion. So the number of hydrogen ion that we have is 0.63 moles of what? Of hydrogen ion. So which means that if 1 mole of this, we call it stoichiometry in chemistry, just relationship between, you know, the reactant and the product. So if 1 mole of this gives 2 mole of this, it means that it's 0.0816 of this will be times 2 because 1 of this will produce 2 of this. So which means it's 0.0816 will produce times 2 of this. Did you understand? So that will give us 0.163. Very interesting, very simple. Very simple. You just need to go over this thing over and over and over again. And that's why I took my time to solve 2 different cases in number 1. Yes, it's stressful for me, but I want you guys to understand this. So you are going for NECO GCE, you are going for GCE, you are preparing for WAEC, you are another level student in any university, you are taking any JUPEP student. Some people are preparing for JUPEP. Yes. All these things are important. The calculations are important. Very, very important. So go through this, share it on all your educational blogs, your classmates, to your, you know, your class groups, WhatsApp group and the rest. And I'm sure it's going to bless them tremendously. I wish you guys success. I've said that if you have not joined our WhatsApp channel, you're a chemistry teacher, a science teacher, or a science student, please try and join the WhatsApp channel because time to time we we dish out a lot of values that will help you. So follow us on Facebook, Chemistry Hangout, on TikTok, Chemistry Hangout, same, YouTube, of course, you should be our subscriber by now. Thank you so much. I love you guys. Till we meet again, remain blessed. Thank you so much.